Okay, this is a video to review radicals for the test. Operations with radicals. Okay, so we have to basically start with, if there's just a number underneath, like say 32, I'm going to think of the biggest square number that goes into 32. So that would be 16 and 2. The square root of 16 is 4, and that leaves the 2 under the radical. We can complicate this a little further by having variables. So, for example, I could have the square root of 25, x to the 10th, y to the 12th. So basically, the square root of 25 is 5. The square root of x to the 10th is the same as saying the square root of x to the 5th squared. So it's essentially like dividing 10 by 2 because it's the square root. Same thing with y. This would be the same as y to the 6 squared, which is going to be y to the 6. So in this case, the whole radical goes away. What happens when there are leftovers? Well, we could have something like the square root of 24 x to the 9th, y to the 11th. So the square root of 24 is going to be simplified to 2 root 6. In here, I can fit 4 x's, because 4 times 2 is 8, and then I'll have 1 left over. And with the y's, I could take 5 out, and I'll have 1 left over. Let's take a closer look at that just to make sure that you're understanding. X to the 9th, we would basically have x to the 4th squared. That's going to get me to 8, and then I have 1 more. So that's going to be x to the 8th times 1. That gives me x to the 9th. This becomes x to the 4th, and I have 1x left on the inside. Okay, so basically then we move to multiplication, division, etc. We could do something like 2 square root of 10 times 3 square root of 3 square root of 2. So this would be 6 square root of, we can do 6 square root of 20. And then this can be simplified to 6 times 2 square root of 5, which is 12 square root of 5. So in isolation, these cannot be simplified, but when we multiply the numbers on the outside by the numbers on the inside, and then we may be able to simplify further. We can do something similar with addition or subtraction. If I had the square root of 45 minus 2 times the square root of 20. Right now it doesn't look like I can do anything with these, but if I simplify each of these radicals, I get 3 square root of 5 minus 2 times 2 square root of 5. So this becomes 3 square root of 5 minus 4 square root of 5. This is now 3 minus 4, which is negative 1 square root of 5. I don't do anything with the radicals on the inside when I add and subtract. But when I multiply, I do multiply the inside. And when I add or subtract, I leave it alone, sort of like if it's x. In other words, 3x minus 4x is negative x. So it's the same idea for 3 square root of 5 minus 4 square root of 5. That would be negative square root of 5. Okay, we also are going to multiply these by FOILing. So we could have 1 plus square root of 2, 1 minus square root of 2. I would have first is 1, my outer is square root of 2, my inner is square root of 2, and my last is the square root of 2 times the square root of 2, which this just becomes 2. These cancel, so I basically am left with 1 minus 2, which is negative 1. If you remember, we talked about these in class being called conjugates. which basically means the square roots are going to go away. Two last things would be rationalizing the denominator. For example, if I had 3 over the square root of 24, you can rationalize first or simplify first. I would recommend simplifying first. This is 2 root 6. And then I want to multiply the top and the bottom by root 6 in order to get rid of the radical. So this would become 3 root 6. And in the bottom, these two times each other is 6. And in the bottom, this is 2 times 6, which is 12. And then I can take this one more step and do 3 over 12, which is square root of 6 over 4. The same thing can happen with variables. So if I had 10x cubed over 40x to the 4th, I would simplify the inside first. So that would become 4x in the bottom. The square root of 1 is 1, the square root of 4 is 2, the square root of x I can't do anything about. So now I have to rationalize. Multiply the top and the bottom by square root of x, so I get square root of x over, this becomes 2x. So we basically don't want to leave any radicals in the bottom. If you don't simplify first, you're going to make it a lot messier for yourself than you need to. So I would say, as a general rule, simplify first. Then whatever's left, you rationalize. It's a lot easier to multiply the top and the bottom by the square root of x than it is to multiply the top and the bottom by the square root of 40x to the 4th. The last type that we had would be if you had something with a radical in the bottom. So in this case, we multiply the top and the bottom by the conjugate of the bottom. And you FOIL the top and you FOIL the bottom. So FOILing the top gives me 3 minus square root of 2 minus square root of 2 plus 2. And in the bottom, we know they're conjugates, so the outer and the inner terms are going to drop. So I just am left with 1 minus 2. So in the bottom denominator, I'm getting negative 1. In the top, I have 3 plus 2, that's 5. And I have minus square root of 2 minus square root of 2, which is minus 2 square root of 2. You can leave your answer like this, or if you want to go ahead and just divide everything by negative 1, you could also have your answer like that. 5 over negative 1 is negative 5. Negative 2 root 2 over negative 1 is positive 2 root 2.